at the beginning, it's actually not so bad to do the centralization, right? As one server can already control thousands of servers. That's not bad. Right? Of course, as time goes, right? 10 years later, they realized that the system scale is too large for a single system to handle, right? But before they reach the limit, they already developed a second generation of Google file system called Colossus, right? That's what they use now. In this one, they do the distributed system. Right? They make it distributed. But at least you say, if you can use a centralized one, feel free to do it. But meanwhile, you should be prepared that you need to make it decentralized if you are very successful, right? Sometime. Okay, so this is more detail about the file system. In the system, the servers are called chunk servers because each file is divided into chunks. And a chunk is just a fixed sized, you can consider it's a fixed sized file, right? I believe the current one is 64 megabytes per chunk. Right? Okay, so in this case, we show, you see, on each chunk server, they hold several chunks. The chunk can be large. For example, you can consider one chunk server, they may have 8 disks, and each disk can be 1 terabyte. So together they have 8 terabytes of storage, and divided by 64 megabytes per chunk. They may have actually hundreds of chunks, right, on each server, right? But here we cannot plot so many. But you say one chunk server, they may hold the chunks from different files. The first chunk on the top, it holds the first chunk of file 1, and the second chunk of file 1, and the first chunk of file 2. Interestingly, you may say that on the chunk server in the middle, it also holds the second chunk of file 1 and the first chunk of file 1, right? So the reason is that, as we discussed, they duplicate, right? So for each file chunk, you will see 3 copies in the system. By default, they will be on different chunk servers. Okay, the system is a centralized system because there is a single master node, right, as shown on the left part. Right? And there are a lot of shadow masters. Right? When the master goes down, the shadow masters can take over. Right? So the application will talk to the master regarding how to place the chunks. And the real data transfer is actually directly between the application and the chunk servers. The master node also manages all the chunk servers, for example, to manage their health, right, to recover if some chunk server goes down. Okay, before we move into the details, any question here about the high-level Google file system structure, architecture? If not, I have one question for you guys. Right? So, as I just mentioned, here you can see the app for a user. They need to coordinate with they need to communicate with the master node to get the chunk mapping. And they also need to communicate directly with the chunk servers, right, to do the data transfer, the access, right? So this makes the system more complicated actually, right? Because the apps need to talk to both the master node and the chunk server directly. It also exposes the chunk servers, for example, the location or the direct the server ID, right, to the applications, right? So there are clear downside of this architecture, right? So why not, right, change the architecture so that the apps just need to talk to the masters instead of interact with the direct access, right? In other words, can we remove the direct communication between the app and the chunk servers? Is the question clear? Right, so can we do this to remove the direct access to the chunk servers, right? So basically the communication between application or user and the chunk servers. I keep asking questions because I don't want to make it just I'm talking you a lot of knowledge, a lot of information. I want you to think about it. The first answer is no, it will increase latency. Yes, but I mean, go through a master, it may not be that bad, right? Okay, the second one is the right answer. So your name is sorry, is Archid or Arcade?
It's Archid, Professor.
Archid, okay. So Archid, you get the right answer. So tell the TA you get also the half bonus point. Okay. The reason is that, remember I told you, this is a centralized system. So we have only one master node. So if everything is need to go through the master node, then the master node will be overloaded. So the system won't be that scalable. Make sense? So that's why you say, even though, right, from the system design perspective, actually you should not allow the user to direct access to the backend, right, to the chunk servers, and you should make it as simple as possible. But because the system is here, the avoid the hotspot, the bottleneck on the master node is a more important consideration, right? That's why in the real system, they choose this one. So the fault tolerant, right? So this I gave you, we talked about that previously, but regarding failures, right, this is a case. Right, so if you have 10,000 servers, right, even for one machine, the machine will last 10,000 days before it fails, which means you can use it for more than 20 years, which is definitely hard to do. But even you can do that, you will have one machine fail every day. Right? So that's why they want to build a fault tolerant software. And the goal is to hide the failure handling from application. Right? So if you use MapReduce or the Hadoop system, you don't need to worry about the failures. Those are handled automatically. Right? From the resources, the sources for failures, one of the largest is configuration. Right? Why? Because first, configuration is more complicated, right? So in a system in data center, there are hundreds or even thousands of parameters for configuration. And this is mostly done manually by a human being. And for a human being, even for expert, to configure those hundreds of parameters correctly is not that easy, right? So that is one reason. Right? Also, if you look at Hadoop system or Spark or other systems like TensorFlow or others, Kubernetes, there are also tons of parameters that you can choose from. Right? Okay, here. This is another project idea you can think about, right? That is how to do the configurations more efficiently. Right? If you can do this one, I can assure you that you can be able to sell your product to those companies easily, because all the companies need the solution to how to do the configuration. The second source for machine crash is a storage system. Storage is even though we have SSD nowadays, but in Google data center, they still use a lot of traditional hard drives, right? Because they are more cost effective. They're cheaper, right? But those ones, as we mentioned, mechanical problem they have all the time, right? And the last point I want to say here is that tolerating or surviving from the failures, that is different from hiding failures. Right. The goal is that the user, they cannot even notice any failure. So basically, they feel like everything is just as smooth as possible. Right. But tolerating is that, okay, there is a failure, but we can survive from that one. But you still need to worry about it. That's kind of a lower requirement. Okay, so since we talk about the project here, and let's spend several minutes on the project ideas. So I have several groups already talk to me, discuss with me about their project. Right? So those are great. So I encourage and welcome more groups to talk with me, right? Either through email or come to my office hour to discuss your project ideas. So the common feedback I can give now, based on my experience, is that what I told you on Tuesday. You want to push yourself harder to find the topics at the intersection of three parts. One is that it is useful to the society. And second is that you have the background or even expertise to do that. The third one is that it's aligned with your short-term career path. Right. So when students talk with me about their project idea, I will ask them for those three, right? To see whether they check all the three boxes. The easiest one to check is useful for the society, right? Because actually you pick any of the emerging technology, right? They're emerging because we need them, right? So that is okay. So it's not, I haven't seen any student discussing any project that is not useful. Right. So it seems that is the part you should worry least about. The second one, often students have challenge is that I will ask them, right? Do you have expertise or background on this particular topic? The reason I ask is that you need to deliver something by the